Good morning, everybody. We had a question. Oh, before that, good morning, everybody. Welcome back to lecture number 12. Today we had the fake quiz, and those who are absent from the fake quiz, it's not good for you, okay? It's not good for you. Because of your absences, students here lost 1 minute from the exam time. Eddy current losses is what we're going to talk about today, but before that, maybe in the homework, maybe in quiz, maybe in the major, we bring you this circuit. How to solve it? You need to find this reluctance, this reluctance, this reluctance, three reluctances. You need to do mesh analysis. You have to do one mesh on the right, one mesh on the left. Here, when you do KVL, it has to be flux left plus flux right times reluctance of the middle. Here you will have flux right times reluctance of the right plus the MMF. Second equation to the left. We're assuming same cross-sectional area, okay?
So,
This is how to solve it, okay?
if we have an air gap in the middle, we will have 4.
You will add, if you have air gap here, you have 4. If you have an air gap here, you have 5. So any change in the direction or change in the material, or of course, obviously, if you have different fluxes. Here we have 3 different fluxes. Okay? YouTube, please keep this in mind when you study for real quiz too, okay? So hopefully the fake quiz today gave you a lesson. What's the lesson there? You have to take it seriously. Because if you don't take it seriously, you will have lots of information. Before the test, you will not be able to do it. We're going to tighten the exam. Time. Today you didn't, it was a baby problem. And you couldn't finish it in 12 minutes. Most of you. What if we assign you 10 minutes for this problem and you find a bigger problem? So exams are hard, Isha. So last time we talked about the hysteresis. I told you hysteresis comes as a form of heat. So same story for an eddy current, it also comes as heat. We all know that the core is made of iron. For some reason there is current that flows in the iron, but iron has very low resistance. Even though it has very low resistance, it still experiences some of the losses. So, according to Faraday's law, the time varying flux induces EMF and current within the conductor, the iron core. So, if I apply AC current, what will be the flux? Ma'ali, what will be the flux? DC or AC? Think. What makes more sense?
AC.
AC. So, if the input current is AC, your flux should be also AC. So if it has RMS, the flux should have RMS. If it's DC, the flux should be DC. It is DC. It is a flux. But it's going to be constant. Think about looped coil.
Okay.
You pass the current and you put a steel. There is a Weber. There are Webers going. But those Webers are fixed. The moment you change your eye, those Webers gonna change. When they change, they induce voltage and current, okay? These currents that are rotating inside the steel, they're called eddy current, and they produce power losses, come up as heat. What is the equation? Similar, except the B has to be raised to power 2. Not between 1.5 and 2.5. And the F should be squared. So which one is worse? Saudiya or Bahrain for the eddy current?
Saudi.
No, Saudiya. Because we use 60. We have more eddy current losses. Okay? But what we get better lighting. 60 Hertz is better. But it's more expensive. Okay? Now, how did they come up with these equations? They brought a thermometer, they measured how much temperature change, they estimated the power, and then they kept changing the frequency, and then they came up with these formulas. Okay? Keep in mind that if the transformer is off, it's going to be room temperature. If you connect it, it will heat up. So one of the reasons is eddy current. What's the other reasons of heat? Hysteresis. Oh, let's go here. What is the solution? Do you remember our core? Do you remember it had laminations?
Yes.
I told you. Watch the YouTube video where I brought it. I'm not going to bring it every time. It's heavy. It had laminations. Laminations are what? Sheets. Why? Think about it. If you have a sheet and another sheet, so the eddy current will be like this. Okay? على شكل دوامات. Surface. Or if you don't have sheet, have thicker, eddy current will swim more. So you cut its swimming path. Get it? So eddy current will spin. بالعربي يسمى التيار الدوامي, okay? According to المعجم. Don't use Google Translate. Use المعجم. That's the proper way. That's the professional way. Okay? As a matter of fact, وزارة الطاقة عندها معجم. Google it. It's very useful. Aramco also has معجم. Okay? So what's the solution for eddy? Laminate the steel. Now it's 50 slides. When you study, take a break. We have covered enough. Maybe if you want to save it in a different document, you can save the PDFs in a separate document. Okay? Control P, number the pages, save it as a new PDF. Okay? If this is too much for you, do you want me to keep it in one big slide, or do you want me to cut it? Keep it. Let's keep our standards, okay? So this is a distribution transformer. What do you see in this distribution transformer?
Sheets.
The casing is somehow looks like a heat sink. نفس حقة الجيمنج لابتوب. No laptop, gaming PC. Think about it as a heat sink. That's why they look like that. Okay? The transformer I bought, is it low power or high power? It's it's high end of low power. 5,000. Still low power. So I remember when I was a kid, we used to have these in our homes because we had the dual supply. Some of you still have 110, 220, but exclusively all the devices now are 220. But back in the old days, you can buy either. Okay? So back in the old days, they used to have transformers in almost every room. And they used to warn the children, don't connect this to here. Some of them, they put papers. They don't connect the vacuum cleaner to this socket عشان ما يحرقها. Business was booming selling electronics. That's why they changed it to 220, because people used to burn it every time. In the kitchen, they used to burn it every time. So for some reason, the government said, okay, we will not have 110, we want to have it 220. It has historical reasons. Why in Saudi Arabia we had both? Because Saudi Arabia, we import, alhamdulillah, we import from many countries. So if we import American machines, we have to put it to 110. If we import Japanese machine, 220. That's the reason, okay? But now we standardized everything. There is economic benefit from the old system. You allow more business, okay? So don't think of it as a bad thing in the past, okay?
ثم اللي كلها بدهم جابوا ال 110 وكبروا متوسطروا وصاروا يبيعوها يعني.
No, the government said we're not going to import any coffee machine that works على 110. But in the old days, you can import it. Some even suppliers, they import both, and they tell you, which one do you want? So if you want to buy a vacuum, do you want to get the 110 vacuum or 220? 220, higher voltage, more power. If you want to get a big kitchen supplies, فرامات, has to do with that. Now it's 220.
طب ايش اللي كان يشتغل على 110 او استمر على 110؟
There's no device down here. The computers with camera chargers are both. Read, I think it's both. It accepts both. Why it accepts both? I'm gonna show you why. Again, it's better to waste lectures on useful stuff. وما حضرنا شيء. So I want to know who's the fourth guy who was absent. So I know this guy, I know this guy, I know this guy who's officially absent, but I don't know the fourth one. Oh yeah, yeah, it has. So I taught before course. Now, why the iPhone charger, the laptop charger accepts both 220 and 110? I'm gonna show you the circuit. Memorize the circuit, okay?
ممكن عشان الافرج حقه عالي.
No.
يعني
That's a random answer. Average عالي.
لا،
Efficiency عالي.
الرينج حق الفولت.
The proper answer is because we use transformers. So look at this circuit, okay? We get 220, 240. We want to convert it to what? To 5 volts. Okay? So what you need to do is you need to get the turn ratio. What is the turns ratio?
10 to 1.
What is this turn ratio?
أكثر من كذا.
No. It's 220 over V secondary. What's V secondary? No, it's not 5. Wrong. This is after the regulator, it's 5. No, it's 5 over square root of 2. We love RMS. This is DC, 5. Regulator works, you give it in 5, كده. Before that, it has to be a sinusoidal of peak 5. So what is RMS? Good, okay. $220 over 5 over square root of 2, which is 60. Random. Do you see this? Taps. I can connect 110 and make this as a full tap and adjust it in a way that I can still get 5 volts. Get it?
يعني لازم أحدد الفترة.
No, they just do it, click button.
Okay.
Or they use Get it? They can use regulators that maintain the 5 volt. Maybe you should get here somewhere else. Maybe 3 or 5. Again, it doesn't matter. As long as you connect it to the supply, you can change the tap. There are automatic tap changers inside, automatic. It sense if the voltage is 220, الcoil يروح التاب هنا. إذا الفولتج is low يرجع على تحت. You can think about solenoid وما solenoid. Get it? Or you can do it manually, like my transformer. My transformer was manually. I was changing the tap. Or there is automatic tap changer, ATC. Automatic tap changer. فالشواحن الجوالات ذكية تقبل 110 220. That is the technical reason. Memorize this circuit. It is transformer, full bridge with rectifier or full wave rectifier, regulator, smoothing capacitor, filter. What is a regulator? Zener. Zener diode. At the end, the Zener diode will give you 5. Even if you get 4, 3, the Zener will give you 5. Do you know Zener diode?
Yes.
Go back to 203. So, get it now?
Yes.
There is automatic tap changer. Even if you don't have it, you still have a Zener. It's not a problem. If it's high power like the one I brought, you change it manually. If it's automatic, either it's automatic change, or you can still have 4 volts, but you get the output is what? With the Zener. Okay?
دكتور
Yes.
الحين الشاحن داخل الترانسفورمر
Yes. شاحن داخل الترانسفورمر. How do you get 220 volt to 5 volt? Get it?
So step down.
Hmm?
Step down.
Step down, yes. واللابتوب نفس الشيء. It's a standard 5 volt adapter. حتى ماكينة الحلاقة.
بس هذه الترانسفورمر الكبيرة هي تسوي ستيب داون
Yeah.
ستيب اب من 11 إلى 100.
My transformer, the one I bought, it can step up too. My transformer, was it step up or step down or both? Both. You remember you took photos. Read it. Okay? We take record. You didn't remind me to give you the control. Please, okay? See it, okay? Okay, enough about that. So what is a transformer? Step up or step down the voltage. And it uses what? AC. Transformers, they have 2 coils that are electrically separated. It means if this coil is burned down, this coil will not be impacted. Yeah, the steel will have some heat, but the coil will not change. Electrically separated.
Different circuit.
Different electric circuit. Or a fancy word is galvanic isolation. What's the fancy word? Google it, okay? Now, because in transformer, are we allowed to use DC? We are not allowed to use DC. And I'll show you in a second. So AC flux and Maini with AC current will give you AC flux. And that AC flux induces a voltage in the secondary side. That is also AC. So don't put DC on transformers, okay? Don't put DC in transformer. And if they ask you in the interview question, assume you connect a battery to a transformer. What is the V secondary? You say, okay, it's 10 ratio and you put 5 volts. You will not get the job. Okay? Why there is an induced voltage? 2 laws. قانون فاراداي وقانون Lenz. Let's start with قانون فاراداي. If a flux passes through internal of coil, the induced voltage in the coil is given by minus N times the change of the flux. If the current is DC or voltage supplied in the coil is DC, the flux is what? DC. Will it have change of?
No.
So there is no induced voltage. Change the source to AC.
Yes.
There is a change in the flux with respect to time, so there is an induced voltage. But why there is a negative sign? Focus with me. Assume this is the secondary side. Assume the primary side is here. We have coils. We connected AC current. What will be the direction of the flux? Let's say that the direction of the flux this way. اللي هو هذا 7. Okay? قانون لينز يقول, I'm gonna explain it بالعربي, then I'll explain it in English. الفلكس اللي يطلع هنا will induce a voltage on the secondary coil بحيث ان التيار يعطيك فلكس عكسي. التيار اللي يطلع gives you an opposite flux اللي هو بالمنقط.
طيب.
To induce الفولت. البولاريتي حقته plus and minus when the current is leaving. I will explain it in another circuit, but let's read the official law. The negative sign is the statement of Lenz's law. What is Lenz's law? Polarity of the induced voltage should be such that a current produced by it produces a flux in the opposite direction of the original flux. So now we have two fluxes against each other. They're not going to cancel each other, but because of that opposition, I experience an induced voltage. Let's look at this transformer. Can we apply it? Let's say this is the primary, and we induce a voltage here, and it's AC, and there is an induced voltage. What is the direction of the flux? Up. What is the direction of the original flux?
Down.
Down here. What is the theorist telling you? There is an induced flux opposing اللي هو بالداش أحمر such that its current no, the current should be now what?
جوا.
Leaving. Why leaving? لأن احنا نشوف الوايندنج من في الرايت هاند رول الأصابع جهة اللفة اللي برا. Get it؟ الأصابع جهة ايش؟ قولوا معي الأصابع جهة اللفة اللي برا. ما تدخل الرايت هاند رول is applied على اللفات اللي برا مو اللي ورا. What is the direction of the current? This way. This is I secondary. So you put your plus and minus. Get it?
Yes.
Get it now? So where is the original flux?
Up.
Well, not up, in blue. What is the opposing flux? Because the opposing flux is in this direction, the current will be leaving. So the plus and minus this way. And now this looks good. Power in equals power out. So we get output current. Does it make sense if you put a load and you put the current here? Or it's better to leave the load? It's better to keep it that way. So unless otherwise specified, those are the directions of voltages and current. Plus, minus, current in, current out. So think of a transformer as a box that has input and output. One key feature about this box, we call it for the ideal transformer, is relative permeability is very high. 1 million. No leakage. No resistance in the winding. No core losses. No reluctances. Why no reluctance? Because permeability is very high. 1 over very high number is a very small reluctance. Look at the directions, and we put dot here. This is what we call it the dot convention. We'll talk about it later. How did we derive the formula EE213? Do you remember this in EE213? In EE213, there is a formula that tells you the flux is 1 over 10 times the integral of the induced voltage. Math is hard. I didn't do well in Math 102, so I'm not going to do it. So if you do the integration, you should have this formula. This is a cheating. He took a derivative. The derivative of the integral is the integral. So if you don't know the integration, you do this trick, and you should be fine, okay? So you find this term. I don't know how to integrate it, so just take the derivative. Keep in mind the flux in the primary originally, before the induction happens. Same as the secondary. Yeah, there is an induced voltage that would cause the ES to appear, but that's the case, okay? Get it? So now I'm going to take the division, I'm going to divide EP, T, Why small e we say? Because capital E is for phasor, small e is for time domain. This expression is made for time domain. Why? Because integration is a function of time domain. You don't want to do integration with phasors. Have you ever seen integrations with phasors? No. It's too much, right? It's too much simplification and too much complication. So don't do it. So that's why we use a time domain. Then you make division. So n primary over n secondary. Cancel the rate of change of flux. You will have this formula. I will fix it. The PDF was corrupted. I don't know why the PDF corrupts the phasors. I need to use another technique. But anyway, this is phasor EP equal NP over NS. I use this formula. Some students won't use this formula, but I prefer this formula. This is easier. Volts per turns is constant. Volts per turns. Volts per turns. It's constant. Voltages are in phase. There is no phase shift. Is there a reason why we have phase shift? No. The minus sign was already taken care of by polarity. Okay? So don't say there's a phase shift of 180 degrees. Now, capital E is for phasor, small e is for time domain. We want to use phasors. Voltage magnitudes vary as you change the turn ratio. If you change the turns, you can change the ratio, you can change the output. So if you want to have smaller output, larger output voltage, let's say that this is a step down, change the ratio, make this big. So you know a regulator? المنظم يعطيك هنا مثلا الريشيو 1.01. So you give it input, it will fix the output to regulator. One technique. You have a ratio close to 1.01, so you keep increasing. We'll talk about it later. For the currents, how to get it, you have to use the complex power formula. What is the complex power formula? Complex power N equals the complex power output or out. Why did we say that? Because this is ideal transformer. No current, no core losses. صح? No eddy, no hysteresis, no reluctances. What's the permeability of ideal transformer? No.
High.
Very high number. What's the reluctance? It's almost here. Again, current in phase, the current ratio is opposite. Here, IP over S, N S over MP. In the exam, if you're confused about primary or secondary, just call it side 1, side 2. Sometimes students have a step up transformer and they call the input side secondary. It is okay to have primary side that's smaller voltage. So if you're scared that you're going to get confused, call it side 1 or left or right. When I was a student, I said in left over in right, because I don't want to confuse myself. Okay? That's a good strategy. Left and right. Instead of primary and secondary. What is the ratio? MP over NS. What is 1 over the ratio? We use 1 over the ratio for the currents and ratio for voltage. Reflection. Do you remember reflecting load in transformers?
الريشيو ده في الامبيدنس.
Yes. So it is covered here, but the formula is very easy. Z load with respect reflected on the primary. ايش معنى البار هذا؟ Reflected on primary. لا حد يروح بنحضر. Equal A square times Z L العادي الأصلية. So you can reflect it and break the electrical isolation. And you can connect it here and get rid of transformer state. You did this in into 13. Okay? Of course, primary voltage also can be reflected. So we call it VP, which is VAS or VS prime. You can call VS prime, but you can call it AVS. Prime means reflection. or IS reflection, you just divide the current. Any question? Okay, with that we'll stop at the dot convention for next lecture. Homework 2 will be released in the weekend. Any question before I stop the recording?
The deadline is tomorrow.
Which homework?
mentioned.
2? I don't know. Homework is the only thing that's coordinated in this course. Okay? Enjoy your weekend.